Hokey dokey. BIT 2406, Chapter 6, number 32. Let's check it out. They say a fruit company contracts with growers in Ohio. Whoops, thought it was a highlighter. Ohio, Pennsylvania, New York to purchase grapes. It's shipped to 2 plants where it's processed. Okay, so we're going from farms to plants, and the supply is this many thousand tons. And they don't tell us what each plant demands, but they do tell us that it goes from the plants to then the distribution centers in the demand of 1,000 tons. Okay, so we have this demand eventually for the distribution centers. They say determine the optimal shipments from farms to plants to distribution centers to minimize total transportation costs. Okay, so it's going to be pretty similar to like 20, 21, 22. Let's see if there's any curveballs here. Probably the biggest difference is like they're not giving us what each plant is demanding. So like we don't know what each plant is supplying, but I don't think it matters. I think you just treat it the same. Like you kind of just ignore that and go about it the same way you would. So let's check out what that might entail. So, all right, here we go. What do we got? We got shipping costs. So kind of dealing with like the first iteration of everything. So from farms to plants, dealing with this. Shipping costs from farms to plants, just given right here, easy peasy. This is the result. So let's bold that. Those were the answers from the solver. They can supply this many 1,000 tons. We have that right here. What's shipped ends up being, I guess, everything. And then what is shipped here, that's just the sum. Okay, so again, as always, however much is shipped is just the sum of these columns, sum of these columns. However much shipped is the sum of the rows, okay? Pretty much all we're getting from that. And then second chart here, so the second kind of iteration, once it's gone from the farms to the plants, it then has to go from the plants to the distribution center. So we're looking across here. The costs are given right here, 23 to 24, 23 to 24, like that. And the values that they got from the solver, the actual solutions, are these that I've now bolded. And then however much is shipped to the distribution centers is here. That's just the sum of these columns. However much is shipped, 155 and 105. It's important to note that, however much is shipped from the plants, that's however much was shipped to the plants. Does that make sense? So from the farms to the plants, Indiana got 155, Georgia got 105. So then those, however much is, shipped to those plants, that just becomes however much is shipped to the distribution centers from those plants, naturally. So, what other curveballs do we have here? We have something about transshipment flows. Let's take a look at this. Notice they're taking B9 minus F14. That's B9, 155 minus F14. 155 minus 155, and we get 0. That's not a coincidence that that's 0. They've implemented these transshipment flows. I think it's the idea that whatever was shipped to the plants must then be shipped to the distribution center. And they have made that so by using an equation. So what they're going to end up doing is, like, the way they made sure that everything from the Indiana plant got sent away from the Indiana plant, like every last ton or whatever they're doing, thousands of tons, 1,000 tons. The way they implemented that is by making sure that the difference between these two cells, 155 and 155, they made sure that the difference between those two cells was 0. They had to implement that in the solver. So we'll see that in the solver. Along with this cell, however much got shipped to Georgia, must have been shipped out of Georgia. They made sure that this difference was also 0, and that's what's right here in this cell. the cost, let's talk about the cost. Keep in mind we have costs to go from the farms to the plants from this chart here. Then we have the cost of going from the plants to the distribution centers, and those costs are here. So they've incorporated both of those in this one equation. So they started off first with the sum product of the B and the I, so that's this, so sum product between these blue and these red. And then they've added, look at the top there, they've added another sum product of these purple cells with these green cells. Okay, let's go to data, solver. We are minimizing the cost, that's the 10,043. Changing variable cells, they have multiple. They have the bold values here and then the bold values here. And then, what is this? They're doing C17, C17, C18. So all these have to be less than or equal to C16. Okay, so they just made it so that however much is shipped to the distribution centers at the end was less than or equal to the demand. Now, hold up. There we go. They made sure that everything that was shipped had to be less than or equal to the demand. Now, I was wondering about this at first. I was confused by it the first time I looked through this problem because if the distribution centers are demanding 90, 80, and 120, how come only 90, 80, and 90 were sent to them? And I realized after the fact, like if you try to set however much is shipped equal to the demand, it can't work. Like the demands cannot be met, no matter even if you set it equal to. It's just like they didn't have enough 1,000 tons or whatever from each of the farms to the plants and whatever to make it work. So this is the best we can do, is setting it less than or equal to the demand and getting the lowest cost we can. I think what happened is like when I tried to set it equal to and then you resolve it, you get a cost that's like a few $100s more, and it's still, as you can see, however much is shipped still doesn't meet the demand. 60 is not meeting the demand of 90. And so even though you set these cells equal to these cells, it still produces something where these cells are not equal to these cells. So the idea is you might as well set it less than or equal to. So that was this one. So we'll change it back to less than or equal to. And watch how this cost changes, okay? It's 10,300, hit solve. Now it's 10,043, which is the right answer, even though 90 doesn't meet 120, okay? Okay, let's talk about the important part that I was talking about earlier. So the equals 0, again, that's from these cells here. They made sure that however much got to the plants was also shipped away from the plants by setting the difference of 80 minus 80 equal to 0, 180 minus 180 equal to 0. Yeah. I swear those weren't 80 and 180 before. Weren't they like 150? I don't know. We haven't talked about this. What is this? Shipped equals supply. Okay, so I think this is just the idea that whatever the farm can supply, they're sending that stuff out. They're sending every little bit of the supply out. Let's see what happens if we change that to less than or equal to. Where'd it go? Oh, there it is. All right. So E6, let's try setting it less than or equal to the supply. I'm just playing around with it at this point. Boom. Cost is 0, but nothing's getting shipped out. So we definitely don't want to do that. Okay. Let's change that back. But this problem's pretty much done. I'm just playing around at this point. I think I've touched on everything I want to touch on. I hope. Yeah, that's all I got. All right. Thanks for watching. If you have any questions, oh, wait, I forgot. There's one more question. I don't think I actually did this the first time I went through this problem. Let's see if we can answer it. They say, what would the effect on the solution be if the capacity at each plant were 140,000 tons? I have no clue. Capacity at each plant. So that would be the capacity of these plants. 140,000 tons. Keep in mind, these are in 1,000 tons. So like if the plants originally got 80 they were really getting 80,000 tons. And if they got 180, they were getting 180,000 tons. So I think what they're saying is like, if the capacity, if the max that each of these plants could have received was actually 140, then this 180 would have to be chipped down a little bit, right? And so what we're gonna do, just play around with it. We're gonna just add that into the solver, and hopefully it like just works out. So what I'm gonna add is that these cells here, however much was received to the plants, have to be less than or equal to 140, because we're speaking in thousands of tons here, right? Let's see how that works. So our cost currently is 10,043. Did it change anything? I don't think so. So, I mean, if I'm not mistaken, if I did everything right here, we're maxed out at 120. They still shipped everything out. And the cost is still the same. So hopefully the answer would be, the effect on the solution would be, it wouldn't change. The solution would not change if we maxed out at 140. So that's the best I got there. I think I did it right. I don't know. Hope this helps. All right. Bye-bye.